All right, so this is our next type. This is x-axis with x equals. We're rotating it about the x-axis. It's nice that they gave everything in terms of y. Just make sure that it is because we have an x equals. So in this one, we will be using this for our ds because we already have x equals 1/3 y squared plus 2 to the 3/2. So now we will do x prime, which is our dx dy. So we will be using a dy for our integral. All right, so if we do our 3/2, we would get 1/3 times 3/2 y squared plus 2 to the 1/2, and then we got to multiply the derivative of the inside, which is 2y. Okay, now we just have some simplifying. So that 2 cancels, 2 cancels, 3 cancels, 3 cancels. So let's do some canceling. All right, we end up with a nice y equals y squared plus 2. And we're going to actually put the square root because the next step, x prime, not y. So x prime equals, why did I put a y? That's the confusing part. All right, let's just, come on, erase, not scribble. Y, there we go. I wanted to put the equal for some reason. All right, so we have y, square root, y squared plus 2. So what I was saying is we're going on to square, so we put the square root, so it's a nice cancel. So now we have x prime squared, which would just be y square root of y squared plus 2 squared. So that's y squared times y squared plus 2, like that. Next we add 1. So since we're adding a 1, we should really multiply this out. So this is y to the 4th plus 2y squared. So that when we add the 1, we can now get our perfect square. So if you remember, just like before we were doing arc length, we wanted nice perfect squares inside. So that was one of the techniques. So you always test this nice polynomial to see if it will square. So we take and square root the first. We square root the last. So square root of y to the 4th would be y squared, basically just cutting the exponent in half. And then square root of 1 is 1. We put plus 1 and square, and we check it. So y squared would be y to the 4th. 1 times 1 is 1. And then we would get y squared and y squared. So 2y squareds. It checks perfectly. So we end up with this. So now when we put a square root around it, it cancels. And we end up with y squared plus 1. That's our dy this time, and that's our ds. So we took it with respect to dy, so our ds would be dy. And so now we have our ds. We can plug everything in. So s equals, and again I have to make my s look like an actual s now, the integral of 2 pi y ds. And so since now our ds has a dy, we leave the y alone. So this is the integral, and put the 2 pi outside. 2 pi integral y, and then we just plug in the ds. 2 squared, y squared plus 1 dy. So I've plugged in my ds. My y stays alone, and there's my integral. So now we just have to integrate it. So 2 pi y cubed plus y dy. So it's 2 pi. And then we end up with 1/4 y to the 4th plus 1/2 y squared. And I didn't put any numbers on there. So we need to go back and put our interval from a to b. And so it is y. That's perfect. So we're going from 1 to 2, 1 to 2, 1 to 2, 1, oops, 2, 1. All right, so we have 2 pi. I'm going to zoom back in again. And then we have 1/4 2 to the 4th plus 1/2, 2 squared, plus 1/4 plus 1/2, but each of those are subtracted. Change our signs, perfect. So 2, 2, 1, 1. And now we can just plug this in our calculator to see what it is, or we can do it by hand. And you would get 21/4 times 2 pi, and then the 2 cancels, giving us 21. Put pi up there already. 21 over 2 pi. We'll write it that way. All right, now all that's left is to verify that our integral is correct for our problem. So we need 21 over 2 pi for this integral, and assuming everything was done correctly here. And usually when you get that nice perfect square, you know you're doing things right. And so we integrated correctly, and we got this. So if it says use your calculator, all you have to do is get to this point, and then it doesn't matter how horrible it is. You just plug it in It gives you the answer as a decimal. But we wanted the exact answer here, so we needed 21 over 2 pi. So you had to actually integrate it by hand. There you go. So we've already done our x-axis now. So it's either this one, they're giving you y equals and you use that one, or they're giving you x equals and you use that one. That's pretty much it.